Okay, so the first one is all about modeling microservices. Okay, how to find microservices from drone business. But before jumping into that topic, let's talk a little bit about the basics. Right? What is microservices? Why do we need it? Right? So, in short, this is what we mean by microservices. This is kind of a typical architecture, N-tier, 3-tier, very familiar architecture, right? With UI API layer on top, business logic, data access, and data, or horizontal layering. Okay, this is very typical architecture for you. Versus in microservices architecture, it's all about the vertical slice of each business function. So it's nothing to do with layering, no horizontal layer at all. So basically, we extract the vertical slice of business function one at a time and make it as a microservices. And it will be a group of bunch of services working together. And most likely, you will have single-page applications or mobile native as a client accessing through API layer to the backend microservices. This is kind of what we mean by microservices. So it's vertical slicing instead of horizontal layer. This is the critical difference from the traditional application architecture. And this is something you really need to understand, because lots of us are so used to the mindset of horizontal layering, right? So we have to forget about this. That each of those microservices may have some horizontal layering stuff inside, but let's not create the data access, common data access layer as a microservices and share that service from lots of folks. That's the wrong mindset. Any questions so far? Everybody okay with this definition? All right. But any time we see this kind of new concept, new paradigm shift, there's always conservative guys like this, right? Why do we need it? The stuff I'm doing, those 3 tiers, works just fine. Why do I need to change from 3 tiers to microservices? So let's talk a little bit about the motivation behind why people are moving to microservices. So this is the common problem with the current architecture. Okay, so in most of the case, for example, in this case, there are 5 teams working on in one applications, and each has its own features, right? Those 5 teams are going through a single release pipeline, going to the production cluster, okay? And when those folks are trying to release the latest update, one of those 5 teams screws up. Like in this case, team A screws up, which causes the compile error in release process, and which keeps everybody else from releasing, right? So since those 5 teams, 5 features are depending on each other, one failure among all of them will prevent everybody else from releasing the latest update. That's the problem. That's a problem of the monolith. That's a problem of 3-tier architecture. And this is why we are moving to a microservices. Even service A doesn't cause any compile error this time, but there may be some implicit dependency between A and C. For instance, C using data schema defined by team A. But team A changed that data schema without telling to the team C. These things will happen a lot of times, right? Then same result. So even it does compile this time, it will break the feature in team C and ending up the same result. The C cannot release the update, causing the whole team to keep from updating. Other, sample of common dependency is data schema, message schema. Your API is leaking some internal details, so that somebody, depending on those internal details, once you change that detail, which will break that guy. And framework library version. Since those 5 teams share the same library, same version, one team update that library, that breaks the others. Or same with shared component, right? Those are the very common cause of dependency, which ends up this problem. Okay? So how can we fix this problem? This is the way microservices works. So instead of sharing single release pipeline, now every team has its own release process going to the cluster. So nothing shared, right? Shared or nothing approach in DevOps. So now 5 teams has 5 release pipelines. So probably running in some sort of container orchestrators. And even when team A screws up again, the other team has no issues releasing their update. So once this guy fixes the problem, team A will update the latest and it gets stable, right? That's how it works in microservices. And this is the primary reason most of the folks are switching to microservices. Lots of guys are saying microservices is good for scalability or resiliency and those things, but this is the primary reason. But it doesn't come to automatically, right? You have to design a model to achieve this goal. That's the key when you're designing microservices. Now I will talk about how to achieve this goal. Any questions? Exactly. So that's a really good point. Actually, I had 2 slides, one for benefit and one for challenges, and one of the challenges slide has exactly the same point that you pointed out, right? But it's not necessarily only for microservices. Any type of architecture comes with benefits and challenges, and this is kind of a benefit, and challenge part is distributed system, because microservices is the highest degree of distributed system. Now, instead of 5, 6 components, we have 50, 60 services running, right? How can we deal with those distributions? How can we deal with data eventual consistency issues, data integrity issues? You'll see lots of those potential issues in distributed systems. So that's a trade-off. Those issues, you don't see it in monoliths. So in monoliths, designing and developing easier than microservices, but you have this issue, right? But in microservices, on the other hand, you get this benefit, but now you see lots of challenges in distributed system. So it may or may not run. And because of that reasons, lots of users try to move to microservices and come back to monoliths because it doesn't work, right? So that's a really good point. I'm not saying everybody has to do this, right? My point here is if you have to have faster deployment, then consider microservices. If you deploy only once a year, you don't care any faster cadence, faster deployment, maybe microservices doesn't give you what you want, right? So it's always trade-off. If benefits goes over the challenges, do it. If the opposite is true, don't take microservices. Right. Yep. I'm kind of oversimplifying things, right, to make it easier to understand. But that's really true. So it's not necessarily monolith, meaning like a single, monolithic piece of applications. So often what you guys are doing today is some sort of distributed, like that gentleman said. there are API piece, middle tier and backend data, and maybe separated into 2 or 3 parts, right? Some sort of distributions there. The point is not the size of the services or number of services. It's more like a dependencies. So even when you have a distributed design, if those components are tightly coupled or depend on each other, right? That has the same issue as monoliths, because you cannot independently upgrade each component. And that is very common issue in here. Exactly. So distribution in loosely coupled manner gives you a same benefit of this. But microservices is kind of going to that end, going to the extreme end of the benefit, right? So we are super cautious when we design microservices. We mitigate the dependency among services. That's the key point. Yeah. Thank you for sharing your experience. So that's another, the challenges with monoliths or highly dependent distributed system, right? So if, let's say 5 teams share the same components, same version of ASP.NET or SQL Server, whatever, you cannot update those components without asking everybody else, hey, I'm updating this to next version, is that okay, right? And it's okay if you have only 10 guys in the team, but if you have 100, 200 members in the team, it's almost impossible, right? And also, if you start with some sort of clean, database schema, over time, like 10 years later, you have no idea who's depending on what schema, what field in which table, right? That is another a very common issue. So, in 10 years, the database is becoming untouchable. Nobody knows what causes this change I'm making, right? So microservices is a way to fix those issues. I didn't mention it, but it's not just release pipeline. Each team owns its own technologies. So since those 5 services are completely isolated from each other, there's no problem. This guy using .NET version, 4.6, and this guy is not .NET version, .NET Core, and that guy is using Java. Or even same ASP.NET, this guy using 4.6 and Core, right? No problem. And without asking anybody, it's kind of a team decision. The same with choice of storages and compute options. Oh, I'm going to use Azure Functions because my task, my workload is kind of event-driven. Versus, oh, no, I'm going to use Kubernetes because I'm dealing with lots of workflow type of issue, use cases. Right? It's not really event-driven, short-lived tasks. It's more like a long-running workflow. So let me choose Kubernetes, container orchestrators instead of Azure Functions. There's no problem doing that. That's another benefit. Technology choices per each team, depending on the use case, depending on the requirements. And you can keep changing that without, asking anybody else. Thank you. Really good point. All right. So I'm going to skip this one, but let me spend 10 seconds. So the question is, how often do you want to update? Right? It used to be not so fast, but this is a survey from a year ago, and 21% of respondents saying they are deploying multiple times a day, and 40% saying a few times a week. So it's getting faster and faster. That's kind of a reason behind why microservices are so popular, because they require a much faster deployment than it used to be. And microservices gives that benefit for you. All right, so now microservices gives you a lot of benefits, faster deployment, technology choices, scalability and stuff. But am I ready? Yeah? Like somebody pointed out, it doesn't give you only the benefit. It gives you a lot of challenges, right? So here's kind of a prerequisite. The skill set for distributed system, spot on. If you are not familiar with idempotency, eventual consistency, optimistic concurrency control, those distributed system concepts, it may be too early for you. You have to learn those distributed system, design before starting microservices. And since microservices should be modeled around business domain, you have to know that business domain very well. If this is a very first domain, for example, if I have no idea what logistic business does, right? I'm not going to jump into microservices because it requires lots of domain knowledge. Even using DDD, without knowing that domain, how can I apply DDD? So lots of folks are actually recommending to start as a monolith-ish, like a less distributed system to understand that domain because it's much safer option, right? You already know how to design and develop. Then break it down into microservices in later phase instead of jumping into microservices. Because, no, just joking. All right, DevOps culture. Since the primary benefits of microservices is the faster release, right? How can we achieve that without DevOps culture? For instance, like automated deployment, continuous delivery integration. Without those things in place, how can I get that benefit? So you need to have DevOps ops culture in your team, including monitoring capabilities. Because now 30, 40, 50 services running, if something goes bad, how can you troubleshoot? How can you identify which one causes that issue without sophisticated monitoring capabilities? So those are kind of prerequisites. And like I said, microservices is not always the best architecture style for you. So this is kind of a hint that you may not need microservices. For example, if you are dealing with very simple domain, you may end up having 2 or 3 microservices. Do we really need it? What's the difference between 1 service and 2, right? So you may not want to go down that path. Or if we are updating an app once a year, you may not need it. Exactly. So his point is even it seems to be simple domain, it may evolve to complex, right? If that is expected, you can start as a microservices. What I'm saying here is it's kind of very simple mom-and-pop web application, right? Do we want to design it microservices? Maybe not. But that's a really good point. You have to think about the long term. If 5 years later it's going to be 10 times complicated, then let's start with microservices from now on, right? Exactly. Exactly. I'll talk about the granularity later. But that's a really good point. So team structure is another kind of metrics, right? So if you can form like 5, 6 guys per team across the microservices applications, that'll be great. But you guys only 5 guys to build a lot of complicated applications. It may end up like 1 guy running 1 team, which doesn't make sense, right? So, but again, team structure is another metrics, and we do recommend 2 pizza principles. Like 1 team should be feeded by 2 pizza, meaning like probably no more than 10 guys in a team, like 5, 6 guys, or kind of a appropriate size. It came from Amazon, right? So it's not just for software design. The smaller the team, the higher the productivity. Because if you have 10 guys, 15 guys in a team, and there is an urgent task, somebody has to take it, right? But if you have more than 10 guys, I really don't care. I don't want to take that task, right? It doesn't look exciting, so I don't care. But if you have 9 other guys, you will expect some of those folks will take it. Versus the size of the team is very small, 3 guys, 4 guys. If you don't take it, you know that the other guys are already busy. So nobody's going to take it, right? So that's kind of a human nature thingy. The smaller the team, the higher the productivity. The same applies to software design, including microservices. Oh, yeah. So if this is the case, then you decide not to go down to the microservices path. You can still make the monoliths, I mean like a current architecture, some sort of distributed system faster, because there are lots of tool chains around the current architecture, right? And people are doing this. Instead of moving to microservices, keep the current architecture and make release process better to get the faster release cycle. That's another option. So you need to think about those things, not blindly jump to microservices. And this is the alternative options for you. All right. So, go ahead.
We should always build the application monolith first. So in the beginning, we don't.
Right. Exactly. So I kind of agree. So when you don't know the domain, going straight into microservices is kind of a challenge, right? You don't know the domain, you don't know the software architecture. Right? It's kind of a combination of 2 difficulties. So let's start with monoliths or something already familiar to understand that domain, then break it down into microservices. Those 2-phase approach makes more sense than jumping into microservices. Okay? All right, so let's talk a little bit about general design principles. Actually, it's very interesting. Okay, so decentralize all things. As we discussed in release pipeline, you have to decentralize things. It might be easier for all of us to think this from opposite angle. So don't do this, right? No central schema management, no central versioning, no central governance. Decentralize everything, because once you have central something, it will break you it will keep you from faster release. You have to ask those central something for permission, right? For instance, if you have some central strong governance with enterprise architects, right? 5 guys, you have to ask me for the approval before changing anything. Then you cannot release your stuff. But you have to release 5 times a day to catch up the market, right? How can you do that? Same with the other stuff, the central data schema or version control. Every time you have to change those things, you have to go through that process, which slow you down. So don't do this. Okay. Model services around a business domain. All of those microservices should be modeled around the business domain. That's another principle from Sam Newman, right? That book. If you are familiar with that book, I'm talking about the same thing. So again, let's take a look at this from the opposite angle. Don't model services around technologies or horizontal layers. Don't create a service just for SQL database or Cosmos database, because we are changing those technologies a lot. Right? Like 3 months later, who knows if you want to change SQL database to Cosmos. Then if you are modeling services around those technologies, you have to remodel it again. process. If you model services around businesses, it's relatively stable. Unless the business has significantly changes, you don't need to change the model, right? And forget about horizontal layers, like data access service across all other business, layers. A wrong mindset. It has to be the vertical slice, and make each service independently deployable. Again, from the opposite side of the things, there shouldn't be any lockstep deployment, meaning service A has to be deployed before service B, because service B depending on service A. That's what I mean by lockstep deployment, right? Let's not do this. Even A depends on B, A shouldn't wait for B to be up and running. Even when B is not up and running, A should be up and running, then grace-free fail. Like, it shouldn't crash. Of course, it depending on B, so you cannot give you a full functionality. But even when B is not up, it should be able to do something, some partial features instead of full features. And no restricted release process. All release process should be all decentralized. Oh, then the last one is data is private to its service. So each service owns its private data. Again, from the opposite point of view, let's not share the data with other services. This is also used to be very common practice in traditional applications, right? One single database shared across all business components. But let's not do this. So it's almost like opposite of what we used to be doing. And we are struggling to change the mindset, even we, right? Francis and I, we were familiar with microservices, so we didn't have a lot of issues, but we have a few more members on the team, and they were struggling to understand this at the beginning of the project. Hey, Masashi, we don't have any governance, right? So everybody is doing whatever they want. How is it going? Like 10 different monitoring solutions. They pick whatever they want. What's going to happen? That's a decent question. But you have to go this way to mitigate the dependencies. See the point, right? So, of course, by doing this, you will see some disadvantages. So you lose the governance. The 5 different teams may have 5 different monitoring or logging solutions. And you have to prevent that kind of thing without having very strong restricted process. So probably some committee type of, way of organizing things instead of having like enterprise architects type of governance, right? But we have to change the mindset from centralizing everything from decentralized. Does it make sense? This is kind of a very significant changes, isn't it? Mm-hmm. Right. Great point. So even we say don't share the data, there is a need for sharing the data. How can we achieve that? That's a question. So the short answer is you can share the data through API. So one service owns its private data. Let's say service A. The service B needs to access that data, but don't directly access that database. You have to go through API exposed by service A to get that data, so that even service A changes that data schema. Unless they don't change API signature, it doesn't break any changes in service B. Doesn't cause any breaking changes in service B. Cool. Yeah, that's the most common way. Another is using eventing or messaging, right? Whenever data changes, service A fires an event, the service B subscribes that event, then update their copy. That's another way. So there are a couple of different ways, all in the document. But I mean, the point is you shouldn't directly access to the data that owned by other services. That is the point. Now we know what kind of benefit we get, what are the general principles. So let's talk about how can we model microservices. We have to answer these questions when you are modeling services. How can I identify services? We are always saying there are 30, 40 services. Where they come from, right? How can I find those service boundaries? What are the boundaries between the services? And what is the right level of granularity when you say microservices? How small or how large they should be? And how do I manage workflow? Because now lots of small services working together. One service cannot complete a transaction. You have to work together to complete one transaction. How can you manage those workflow? And whenever those services working together, there will be lots of inter-service communications. How can we manage it? And how can we mitigate the service dependencies? Those are the questions in modeling phase, right? How many of you are familiar with this domain-driven design? How many of you have already read these two books, or one of those two? Good. So, 20-30% already know, but for those who are not familiar with yet, or even for those who already know, let's recap what DDD means. Okay? So in short, it means DDD is approach to design software by putting business domain at the center of the process. And it has two kind of elements, strategic modeling and tactical modeling. Strategic has a larger scope. Right? It's more like defining business domain and bounded context. And the context maps shows you the relationship between bounded context. Versus tactical modeling is for each bounded context, going into each bounded context and break it down using building blocks. And those concepts of DDD can be applied to different type of architecture, like hexagonal architecture, layers, CQRS, and including microservices. And I will show you some basics of these concepts. But when should we use domain-driven design? And this is kind of a graph that shows you when you pick DDD versus others. The other two options here is transactional scripts, like ASP.NET or PHP, a bunch of scripts, right? Or table module is data-centric approach, maybe using ER diagram to model the data, and then have some business logics around that data model. That's kind of a data-centric approach. DDD is domain-centric approach, right? Business modeling and start from there. And DDD gives you the most benefit when the domain is complex, like this point, right? Until this point, it gives you overhead. Like for the simple domains, let's use ASP.NET, start scripting it, right? With some sort of database behind, that's fine. But if you go beyond some complexity, DDD start giving you a lot of benefit. And here's an example of what we did in drone delivery project. So we started with, hashing out some rough sketch of the business domain. I mean, this is just an example. I'm not saying you have to strictly follow this process. I'm just giving you what we did, right? So we start with rough sketch of business to understand what this logistics business, drone delivery means. Like what are the features? So shipping is kind of a core of this business. We ship packages using drones. But in order to use drones to carry the package, you have to have some sort of drone management features. And you can share that drone with other businesses. And for long distance delivery, you have to ask third-party logistics like FedEx for, using some trucks. Like drone cannot fly more than 100 miles, right? So for long distance, you have to work with third parties. So this is kind of a rough sketch of idea of how this business runs. Then I'm just skipping, intermediary, but this is how we end up having a domain model, right? Domain represents the business, the problem areas. So the shipping, again, is a core domain with a few subdomains, like call center. If something goes bad, we have to have call center to help the customers. And third-party transportations for long-distance delivery, drone management, and accounts for user management. And when you want to share that drone with other folks, drone sharing is another problem domain, right? And in greenfield scenario like what we're doing, ideally, there should be one-to-one mapping between domain and bounded context. Again, domain represents the business problem areas. Bounded context represents the solution we are building. So there should be one-to-one mapping in greenfield scenario. It's not necessarily the case in brownfield. Anyway, so we ended up the domain model like this, and the context mapping. Each bounded context depends on what, right? So this is kind of a starting point. And when you define the context map, the relationship between bounded context, there are two types of patterns. One is tightly coupled, another is loosely. And of course, loosely coupled pattern is better because it gives you less dependency over the other. So you should design the bounded context in a loosely coupled manner as much as you can. Well, the example here is tightly coupled. Like one of the tightly coupled patterns, shared coded patterns, is like this. Like bounded context A and B shares some sort of assets. This is the common examples: code, data model, or infrastructure like messaging or some others, right? So whenever bounded context A would like to change those assets, it will affect the other bounded context. That's why it is tightly coupled. You should avoid those relationships between bounded contexts as much as you can. So once you figure those list of the domains and bounded contexts, you can now start looking into each of those bounded contexts and break it down using building blocks. And this is a list of building blocks. I will show you one. I'll show you the brief, explanation of, those elements. Let's start with value object. This is a immutable object, meaning like there's no history maintained, right? So for example, like email or phone numbers, that's just a value. You can throw that away and create from scratch. That's what I mean by immutable. Value object is like this. And the benefit of using value object is you can use it for API signature. For example, if your API has 5 parameters, you can package those 5 into one value object and then use it as a part of API signature. Then simplify that API. And also having value object, if somebody sets a new value to that VO, you can do some validations, right? Internally in the value object instead of leaking that validation logic to the client. Same with error handling and data handling, and it gives you better testability. And on the other hand, entity has a identity, meaning it has a history behind, so it's not immutable. So like a user. Masashi, there's only one Masashi here. We cannot throw a Masashi and create Masashi from scratch. This is not just the value. It is an entity with history in it. And it can have attribute and behaviors. And if you have to have a relation between entities, you can have a reference going to that entity, and you can track changes happening on that entity using event sourcing pattern, meaning like you can keep firing that event, the change, history of the change as an event, and you can keep firing that event and store that event somewhere so that you can see that history. An example of entity could be user or product. The aggregates is a group of entity and value object, and it can define the boundary of persistency. So anything within the same aggregates share the same persistency boundary, meaning everything in the same aggregates are always consistent. But anything outside that aggregate can be inconsistent. You know what I mean, right? So it defines the boundary of the consistency. That's what aggregate does. And when you design aggregates, the size is a key point. If it's too small, it may give you some fragmentation or data inconsistency, integrity issues. If it's too large, loading and saving takes a while, right? So when you design aggregates, you have to think about those things to find the right size, right spot. And like entities, you can maintain relationship going to the other aggregates by reference. And a good example of aggregates are user accounts, subscription. User accounts can have a list of members, right? It's not just one user. And it also has user account status, silver, gold, premium, whatever, or organizations that those members belong to. So it's a group of entities and value objects as aggregates, but they share the same persistence boundary. That's what aggregates are. The domain events are also important because now each aggregate defines the persistency boundary. There are multiple of those, right? When you want to subscribe the events happening, the changes of the data happening in other aggregates, this is what we do. So the aggregates, entities can fire the events of data changes, then everybody else who's interested in that data can subscribe that events, then do their own process. Example is order placed or delivery completed. So this is kind of a business level events, not technology, right? It's not like one data entry deleted from SQL database. That's a technology events, which is not domain events. This should be the events at business. Domain services are the good place to put some stateless operations that spans across multiple aggregates. If that operation within one aggregates, it can belong to that aggregates, right? As a method, as an attribute, behavior. But if, let's say, some workflow that calls 5 different aggregates cannot belong to one aggregate. That's a good example of domain service. So some sort of workflow, business logic, those operation has those business logics that cannot belong to one aggregate will become a domain service. And examples of the domain service is delivery scheduling process. One of the workflows we implemented. Well, let's not overuse domain services because that's so easy to put everything into domain service. Oh, let's make this as a domain service because we don't know where it should belong to, right? And you end up like having hundreds of domain services. That's kind of a pitfall. So let's not do that. Let's make each aggregate specific behavior into that aggregate, not here. This is the place only for the operations that spans across more than one aggregate. Application service is kind of similar to domain service, but this is app specific, not domain. So this guy doesn't have any business logic in it. So for example, like task coordinator or sending DTO or managing the transaction across database, there's no business logic in it. This is a concern about application level, not domain. Those are the similar but different type of services. The examples are user authentication, sending DTO, those up-level concerns. And this is kind of a relationship between these, 5, 6 different elements. Like app services are client of domain services, which goes across more than one aggregate. And one aggregate can have a reference to maintain the relationship between. And whenever you want to have you are interested in the changes of the data happening in different aggregates, you can subscribe events coming from that aggregates, then do your own stuff. And each aggregate defines the persistency boundary, meaning like aggregate 1 have their own persistency mechanism. Aggregate 2 has its own persistency mechanism. Right? Now, if you apply this idea to drone delivery business, this is how it looks. So the gateway is a very good example of application service because gateway doesn't have any business logic in it. It just routes the request to backend services or do some, of cross-cutting concerns like user authentications, throttling, right? Nothing to do with the business, but it takes care of application level concerns. So that's a good example of application service. Versus scheduler takes care of the workflow going into the backend service. It has a domain service, right? When you want to complete the transaction, you have to work with those services. That is a domain knowledge, right? So the scheduler here is a domain service. Delivery and drones are the aggregate, works together with this guy. And delivery history takes care of archiving and analyzing the events happening in delivery. But like we discussed, those two aggregates, microservices, shouldn't share the same data. So the delivery aggregates, the filing, domain events, going to delivery history aggregates. And the history stores that into archive and also do some sort of analysis. This is how we apply the DDD concepts into a drone business. Any questions? Does it make sense? It may kind of a new to you guys, but this is very common process when you apply DDD to your business to model microservices. This is a process using aggregates, domain service, app service, and domain events. So what I'm saying is that aggregates and domain service and app service are very good candidates as a microservices. I'm not saying all of aggregate services will become microservices. It's not always the case, but they are good candidates. And once you have a list of those things, now you can see which one of those aggregates and services can be microservices and the others are not. Right? This is a way you find the services. Sounds good? Right. So, just to recap this process, you can start defining bounded context by going through domain modeling, right? And like we discussed, bounded context is a linguistic boundary, meaning like it's a model language boundary. If you mean by customer is different from what I mean by customer, you and I are in different bounded contexts. But if you mean by customers the same as me, we can be in the same bounded context. So bounded context defines the linguistic boundary, modeling boundary. Okay. So once you identify those a few bounded contexts, any number of bounded contexts, now you can go into one of those bounded contexts and start breaking down using building blocks. Aggregates, domain service, app service, those three elements are very good candidate as a microservice. That's where we are now. And the next step, I'll show you in next slide, is you can do a further breakdown from non-functional requirements. So once you identify service candidates by going through this process, now you can think from life cycle point of view. If one service has two different features, and those two different features has different life cycle. For example, feature A is daily update versus feature B is update once a year. Then those two features could be split into two different services, right? Because if they get merged into one, you have to always deploy the feature B. It's not necessarily be updated, right? It's annually versus daily. The service A requires to update daily. You have to update both. So you can split those into two services so that you can independently deploy service A from B. And same with quality attributes. If feature A and B are living in same service but has different scalability requirements, A needs to be scaled out like significantly, 10 times more instance versus feature B is kind of fixed scalable. You don't need to scale. You can split these two into two services and assign lots of instances only to service A, not service B. And same with availability. Feature A requires 4.9 versus B requires 3.9. Now you can split them into two and give A more instance and give less instance to service B. Right? So that's the quality attributes point of view. And technology use, if you want to write C# into for the feature A and Python for the B, you can split them into two and use different technologies, not just programming languages, but storages, messaging mechanisms, framework versions and stuff. Any technologies, if you want to use different ones for any reasons, like a team skill set or whatever, you can split them into separate services and use different technologies. And team structures. If one service requires too many members, like 15 guys, it is a good hint that you can break it down into smaller chunks so that you can follow the two pizza principles. And once you go through this process, find the service candidates, refine from those non-functional characteristics, then as a kind of a final step, you can validate the service granularity. And this is a KPI. So each service should own single responsibility. And also life cycle. So any features within that service share the same life cycle. And the team size should be two pizza principles, 5, 6 guys probably. And there shouldn't be any chatty calls between services. Because if service A and B calls a lot of times, it means that there is a tightly coupled relation between, right? So it means that those two services can be merged into two. So some folks are saying smaller is better, but that is not true from my point of view. because this is obviously, if you break down too small, it will cause you this issue, right? Tight coupling between two services, right? Or lockstep deployment, because A depends on B, and A needs service B to be up and running before A gets deployed, right? Those things will happen if you go too small granularity. And same with data consistency, because each service has its own data. If each service gets too small, then data gets fragmented and ending up having eventual consistency or integrity issues, right? So if you have too small granularity, you'll see those issues. And whenever you see those issues, you will merge them together and make it a little bit larger. All right, so that's kind of a general step of modeling services. And I'll show you examples from drone delivery process. And we started with domain model, like this is the one I already showed you. And then started breaking down each of the bounded contexts. This is kind of a breakdown of shipping bounded context. And we did a service mapping. So like I said, the aggregate services are good candidates. So we decided which one should be the services and the other one shouldn't. And as a final step, we did some more further refinement from non-functional point of view. Then two of those services has been split into more than one. Okay, so then this is kind of a final, high-level design we ended up. Let me show you one step at a time. So when you model the business, you can use ubiquitous languages like this. This is one example. So I'm not saying that you have to always do this, but it has to be a business language, not technology. Right? So let's not use sacred database from the beginning. Right? So it should be written using business terminologies. And you should work with domain expert who knows that domain to analyze that business. Right? So this kind of example. And you can start with the idea of finding nouns as a candidate for entity, and then verbs as a behavior of that entity. Right? It's not mechanical. It's not that mechanical, but you can start with that idea, then repeat the refinement. That's what we did, like finding nouns and verbs, entities and behaviors. But we often find that, I thought this is a kind of an entity, but it is really not, right? But you have to go through those, going back and forth, lots of iterative process to find entities, aggregates, services. And then, at the end of the process, you can find the domains and bounded context. And let's look into one of the core domains here, shipping. And by going through those business process, business analysis, this is what we found. The one in black, the domain services, then one in gray, aggregates, the list of those things. And one in this light gray is an event between delivery and delivery history. This is kind of a result of doing business modeling. And then finally, we found that the items in navy blue are microservices in this bounded context. And then another item in white with dotted lines, services running outside this bounded context. This is also another common kind of situation. You have to make decisions of which one should be in this bounded context. The other one should be in external bounded context. And there are 3-4 factors you can, think from, like network latency. Of course, something running within that bounded context gives you shorter latency. smaller latency versus something running outside a cluster. You will see much more network latency. Another is team structure. If you depend on services in external bounded context, you have to rely on that team. Versus if you have some broker running within your bounded context, you own that service, right? You don't need to ask anybody to change anything. You own that stuff. Then this broker can take care of any communication between this BC and external BC. And some, data schemas. If the drone in this bounded context is very small subset of drone service in drone management BC, you may want to have some different drone service running in this BC. But if those two drone services share mostly the common schemas, common responsibilities, there may be no point like separating these two into two different bounded contexts. So based on those factors, you can make the decisions. But this is very common situation. If you want to have all services running in this bounded context, or relying on external bounded context for some of the microservices. And this is kind of a final step in modeling. So now we have list of microservices, but from the non-functional requirements point of view, what we found is that those two services used to be one scheduler service, but what we found is that this service has too many responsibilities and also different scalability requirements. What this service does is to accept the request coming from the client, then do some sort of load leveling. Like we are dealing with production quality requirements, right? So we are dealing with 100K requests per second. But we don't want to, we don't want to let those spikes going into the cluster. So we do load leveling at this, service. That's one responsibility. That's one big responsibility. Another one is the scheduler side of the story. This guy manages the workflow going into 5 backend services. So we didn't want to put those two big responsibilities into one. And the scalability requirements are also different. This guy has to scale out to deal with the peak of the load, 100K, versus this one doesn't, right? So because of those reasons, we split one service into two, ingestion and scheduler. And similarly here, the scheduler service takes care of the workflow, and it's fine. It's fine for the happy path. But if something bad happens, who should take care of it, right? So again, if this guy takes care of everything, it could be too much responsibility. So we split this into two, scheduler and supervisor. Supervisor takes care of all partial failures, and scheduler focuses on happy path. Okay? All right. And to finish this process, you have to think from service interactions. Who calls what, and how to make it scalable or resilient. Right? Some components fails, but it shouldn't affect the whole system. To do that, you can apply those bunch of design patterns, which is the topic for the second session. But before going into the second session, do you guys have any questions? No, actually, we are doing it parallel. So the design we did here is that the mobile app here can make requests as a one call. There's no multiple going back and forth, right? And each request are going through this event hub. I'll show you some more designs in detail later. Then this guy picks up that message from the event hub, then manages the workflow going into 5 backend services. But those processes are running inside the same Kubernetes cluster. So there's no network latency. It's not zero, but it's kind of really fast. Those calls are done within the cluster. Yep. Versus this one is kind of outside of the workflow. So this guy is running on Azure functions outside the cluster. But it doesn't matter because there's no network latency issues. Yep. Exactly. That's exactly what we did. So for the status inquiry, it wouldn't go through this pipeline, right? It goes directly into delivery service, which stores the status in cache. This is actually the Redis. Yep. Make no sense. We did a path testing with 30K requests per second. Yeah. So enterprise LOB, you don't need to scale out that much, right? So this might be overkill, but we thought that bigger contains smaller, right? So for low throughput system, you may not need this part, but you still need somebody manages the workflow going into the backend services. And each service owns the private data here. Package owns package data here. Delivery owns delivery data. History owns archive and status data. But point is that the reason why I chose microservices is each of those services have to be updated like a daily, right? So there's almost no dependency between. We can update the package service without breaking anything in anybody else. That's the reason why we chose microservices. Yep. Exactly. But short answer is it can be either way, depending on consistency requirements, right? So if it has to be super strong consistent, you have to merge them into two and have one single database backing up. But most of the case, that's not required, right? That's true for this case. It can be eventually consistent. So we are using compensating transaction instead of ACID. I'll show you in the next session, but that's a short answer.